Alrighty, so what we're going to do to find the gravitational field is use this formula, which actually is in the data packet. It's in gravitation, so it's not in the actual field theory section. Okay, but this one actually is in there, right? And this is for a point that's r from this mass, right? So what we're going to do is we're going to figure out these gravitational fields. And these gravitational fields are, mass is always easy, right? It's always toward the mass, right? So if this is sort of, we'll call that one A and we'll call that one B, right? The gravitational field of A is toward A, and the gravitational field of B is toward B. So there's never that insecurity you have with charges, right? Because charges can be it's away from positive toward negative or something like that, right? So let's figure this out. The gravitational field due to A at P, right? GA is going to be, G is 6.67 times 10 to the minus 11th. And then mass A is 2.7 times 10 to the 24th. And then our distance to there is 1.8 times 10 to the 6th. And don't forget to square this thing because it's a field, right? All right, so 6.67 E minus 11 times 2.7 E24 divided by 1.8 E6. We got to square that. So this is 55.583. A lot of threes there, right? And that's newtons per kilogram. And this is to the left. Okay, now here's how I know that, right? We're at point P, and mass A is there, and we're trying to find the gravitational field due to it. It's going to be always toward the mass. And since mass A is to the left of point P, this field is to the left, okay? And then the gravitational field of B is going to be 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared, right? Times, and then B is 8.2 times 10 to the 24th kilograms, and then we're going to divide by, and this distance is 9.1 times 10 to the 6th, and then don't forget to square that, right? And this is meters squared. Now what happens to the units here is the meters squared go the way of the bison. One of the kilograms goes away and you end up with newtons per kilogram, just by the way, right? Okay, so let's see, I've got this, and I'm just editing the old one that I just typed. So 8.2 is our distance, and 9.1 times 10 to the 6th is our, 8.2 is our mass, and 9.1 is our distance. And this is 6.604 to the right. All right, so now we must do, drum roll please, we must do the final calculation, okay? I'm going to make the to the left negative, I'm going to make to the right positive, that's what I always do. Okay, so the total gravitational field is going to be negative 55.583 bar plus 6.604, right? This is just this guy and this guy, right? I'm making this one to the negative because it's to the left. And this one's positive because it's to the right, okay? And that's the trick. I mean, the kids struggle with these, right? So that's the thing to practice. Just figure out what the direction is. And okay, so let's see. The opposite of this number plus the number I just got. And I get negative 48.978. Now the hardest thing, this is newtons per kilogram, right? So this means it's to the left. The hardest thing here now is how do you write that with 3 sig figs? We're rounding to this place. We have to round up, so it's 49.0 newtons per kilogram left. Okay? Now if you say negative to the left, I will interpret that to be to the left. Okay? There we go. All right.